Okay, so welcome to the 2022 mock exam question C1 Geological Geometry. So we've got ground contours at 5 meter intervals, scale 1 is to 1000. Okay, ABC is the centre line of the proposed roadway, OC is the centre of a circular viewing area. The roadway has the following specifications. A to B is level at an altitude of 50 meters, B to C is falling uniformly at 35 meters. Slopes 1 and 1 for cuts and 1 and 1.5 for the embankments. Complete the earthworks necessary to accommodate the roadway between A and C, and B, the southern side is already done. Okay, so cuts, slope, okay, as you go out from the roadway 1 unit, we're going up 1 unit, or as I should say, as you go up 1 unit, you go out unit, as opposed to say go out 1 unit first and up 1 unit. Okay, embankments, right, as we go down 1 unit, okay, we're going out 1.5 units. So if we go down 5 meters, okay, we're going out 7.5 meters, as the scale is 1 is to 1000. Okay, scale is 1 is to 1000. So for roads or cuts, if we go up 5, we're going out 5. Now, okay, so we've got embankments, right? So for this, here's 50. Okay, the road is level at 50 meters. So 45, 40, and 35. So we're doing, okay, for the circular area, this is an embankment. For the circular area, as the ground is higher, as it says, A to B is level at 50 meters. Right, now, so I'm going to mark out 15, okay, and then I'm going to get my compass, and I'm going to bisect that for 7.5, and I'm going to swing arcs then for the embankment, okay, on the circular area. So 7.5, so 15 there rather, okay, this is halfway, last one, and then be as accurate as you can, very important. There's the next one. Right, compass on O, we're going to swing, arc here, next one here. Now it's just look at them. 7.5, 7.5, yeah, 7.5, so I'm happy. So this one is at 50. For embankments, the numbers get lower every time you go out, okay, from the road. So that's 45, 40, and 35. So here's 45, okay, 40 and 35, okay, so and we can freehand sketch them in, okay, tadpole swim up. So that's an embankment there. Now, okay, the road is going for A to B, okay, we're going up in 7.5s. So A to B is level. Right, so I'm going to do that now. So 55 there. Alright, well that wasn't even needed there, because what was a waste of my time there, as there's going to be absolutely no embankment there, because it's a cut. So just going to get rid of that. Now this part will be a cut, and the slopes are, okay, 1 is to 1, so we're rising in 5, so 5, 10, okay, 15, 20, probably won't need any more than that, okay, nope, I'm not, so this is at 50, 55, 60, okay, so a horizontal line there from 60, okay, until we hit the 60 contour, okay, and 55 contour. There we go, and then there's back at 50, okay, there, and right, I've got another 60 here, 55. I'm going to lightly sketch them in there because the reason why I'm going to lightly sketch them is because B to C is sloping, or is falling, what did I say, sorry, B to C is falling uniformly, is falling uniformly to a level of 35 meters at C. So from B to C it's going downwards. So this point here is, okay, 35 meters. All these numbers here are going to be above it, so we've got a cut to do, right? And this is B1. Right, we've got to calculate the vertical distance from B to C, okay, which 50, 35 is radius 15. So I'm going to take my compass and I'm going to draw in a semicone radius 15. Now, I'm going to join the base here to it as a tangent. This line is at, this line is at an altitude of 50 meters. Now, I'm going to draw lines parallel to that, and I'm going to space them every 5 apart. Okay, just fucking walking the way here in school. Now I'm going to mark 5s along that. Now the reason why the cone was radius 15 is because the cut slopes have a ratio of 1:1. So if it was 1:2, the radius of the cone would be 30. Okay, and the distance between the lines will be 10. Okay, that's important to note. Now, you can draw lines parallel to this one here. Should be plenty. So there at 50, okay, 50, 45, 40, okay, I might need one more, right now, so 50, here's the 50. Here's the 55. The 55 line is hitting it. 60. Okay, 45 is there, and the 40 line is there. Now, next one here. Okay, so there's 50. This is 45. Then again, it's hard to know that, in fairness. And then this. Okay. This anticipating that runs around the contour. Okay, and then another 45 here, 50, okay, 55, 60, 60, now 55, okay, 50, 50, 55, 60, and then 60 there. So this is where that old level section is going to stop. It's going to stop right there, and technically there should be a heavy line right back there to B, because the two surf slopes change, right? Then we can freehand sketch these in. Right, and then our tadpoles going up for, going the other way around for cuts, swimming upwards so the head is away from the road. For cuts, right, part B. D, E and F are 3 points on the top surface of a stratum of ore. D and F are an altitude of 10 and 45 respectively. The stratum has a strike of 60 degrees north east. A strike of 60 degrees north east. Okay, now I'm going to join these together. I'm going to do an elevation. Cut these in. So I'm going to draw it in up here in the space provided, right? D. So we'll say this is a 10 meter line, right? Well, what does it say? D and F have 10 and 45. So D is a 10. E then, okay, is up 5 and not further 3 because we're starting at 10 meters. So to further 35 from there, right? That's F. Now we can join D to F. Okay, how do we get point E? Right, so the strike has the stratum has a strike of north 60 degrees east. So it's like north 60 degrees to the east. So this is actually going to be a 30-degree line in our plan view. Okay, the reason why we're doing this is because we don't know how to find, we need to find the altitude of point E. That's why we're doing this thing here, this strike line in plan first. So this is the strike. Determine the dip of the stratum, so the angle that it makes to the horizontal planes. I'm going to look along this strike because the stratum is going to project as an edge view in an auxiliary elevation. Right? Now, I'm going to draw in my x1 and y1 line. I'm going to take my heights from my elevation. So there's D1. Okay, F. So there's F to D1. Okay, now that is the altitude of point E. Alright, in elevation, that's the altitude. So I project E up and I take the height of E1 and I plot it here. And there I can join it back to D, right? So that's the elevation of it. And watch how that works, look. If I drew strike is a horizontal line in elevation, a level horizontal line on the surface of the stratum, a level line. So if I drew a horizontal line from elevation and drop that down to plan, that's a strike there. Okay. So part 3, the stratum of ore is X2. extended to intersect the cut surface on the north side of the roadway between B and C. Find the line L to L1 which represents the intersection between these two surfaces. Ooh. Now, I forgot to mark in the dip, right? I'm not really sure. Okay, so the last part, hard little one right here. You have to stratum vortex extended to intersect the cut surface on the north side. Find the line of intersection. The stratum projects as an edge view here. So the line of intersection is located, okay, on this edge view of the stratum. So you can extend that in there. Right, okay, I would encourage you to pick 3 points on the surface. So here's one at 50, 50, and 60. Now project these up here, okay, to my auxiliary. Alright, so plot the 60 height for me. I had to go mark it 50 from the X1 and Y1 line because I started D1 at 10. And then 40 and down here 40 as well. Right, so here I've got a point. $50, $50, and $60. Right, now I'm going to join them together. Okay, now the line of intersection where the edge view, so zoom in here. So you can see I've done it before there, or you know, you can see I've already done it and made an error at it. So not an easy one, okay, but it is a brilliant question as it intertwines find the line of intersection between two surfaces in dihedral angles or in intersecting surfaces and surface geometry. So it is a savage question. Right, here's a point on the line of intersection L to L1. So there's L, there's L1. Now this lies on the 60-50 line. Yes, I'm going to bring this back down until it intersects there. So there's L1. Alright, now I'm going to bring L back until it intersects the line here. Okay, now there's 2 points in the line of intersection, L to L1. Okay, and we can line them up there and heavy them in. Okay, and there we have it. There, or it's might be slightly. Let's just check it. There's just a bit on. Very bad presentation for me there. So it is very, very poor. Okay, but that is a class question as it combines intersecting surfaces in a geological geometry question. Right, brilliant.